Hey guys, welcome back to the channel. We're going to continue on with our PLC ladder logic training. This is the third video in my series. I'll put a link to the first two videos in the description below. Today's scenario is going to be, we have a conveyor motor and we just need a simple circuit to start and stop that conveyor motor. We're using the online simulator called PLCfiddle.com. This allows us to keep everything generic because we're not worried about a specific programming brand of PLC. I think if you understand one kind, you can understand them all. So let's see, if we're going to do a motor, conveyor motor, then we're going to need a start push button, which is going to be Boolean because it's on and off. And I named it I1 for input 1, and we'll do input 2 for the stop push button. Then for our motor, that's going to be an output, so we'll do O1 and we'll do motor. Again, all these are Boolean. And then just for demonstration, we use some internal memory, which we said we would name them with the prefix M for memory. So we'll have M1, and we can do something like start motor memory. Let's see if that's enough for us. So we'll do it two ways. First way, we'll put our start button in here, and we'll put our stop button here, and we'll use a regular coil. We're gonna give this our memory address, and then we're gonna add a branch. There we go. It's our memory. And then we're going to make our memory cut our motor on. So there we go. This should get us pretty close. So the way this works, whenever we press the start button, let me cut this memory off to get us started right. Not sure why that was on, but probably from the last time I used the program. Alright, so our motor's off. I'm going to come over here, I'm going to press the start button. Right, that allows the logic to flow. The stop button's off, and notice, see over here it says it's off, and notice I programmed the normally closed contact for that. That way the logic can flow right through it. So we got the start button pressed. It's going to go right through our stop push button normally closed contact, and that's going to allow our coil for our motor start memory to come on. Alright, now once I let off the button, I'm going to turn my start button off. That's me letting off the button. This little branch right here around it is how the logic is going to flow. This is going to allow our memory to stay on right now. So even though I've let go of that start button, it is considered to be sealed in by this branch right here. And the way this works, this coil and this contact are connected together. They're associated because they share this same address, this M1 start motor memory. See up here, M1 start motor memory. So the coil, he leads the contacts. See, this is another one of his contacts right here. So the coil is the leader and the contacts follow his lead. So when the coil turns off, his two contacts will turn off. But right now, because he's on, the contacts come on. So this contact is serving the purpose, like I said, of keeping this rung going. It keeps it sealed in because I let off the push button, but that logic comes and it hits this branch around and keeps flowing up and around like that. This second contact for that memory is what we're actually using to run the motor, our output, like that. Now we could have done it all with just the output motor address. So let's rearrange it for just a second. let's make this the motor. Let's make this a motor. And then we'll just get rid of this rung right here altogether. So we could have done it like this and not used internal memory at all. But whenever, this is just a rule that I like to use. Whenever I'm programming outputs, I don't like to use their contacts anywhere. So the only place I want this output used is on the actual output. I don't want that address used anywhere else. The reason that I do that is because you in PLCs you can place a manual override on an output. It's called a force. So even though the logic may not be telling this output to come on, you can usually right click on it and force it on or force it off, whatever state you want the output to be in. And if this is the only place I've used that output, I don't have to worry about affecting anything else. Whereas if I have a bunch of contacts off of this output, then if I force this on, then its contacts may cut something else on that I don't want on. So just as a general rule, I only use the output address on the actual output. And to allow that type of stuff to work, I will use internal memory to do this. So let's put it back like we had it. Alright, so we've got our M1 memory is cutting our motor on. So let's press the stop button, see what happens. So when I press the stop button, this contact is no longer green. So that logic was flowing down around this branch, but when it hit this, when it came onto that scan and that stop button was pressed, that broke this circuit. It became unsealed. So that cut the coil off, which meant that these two contacts that follow his lead, they turned off as well. So that cut our motor off. Now when I let go of the stop push button, it can go back green, and this is because I've got that normally closed contact there. So let's look at one thing right quick that I may not have mentioned, or I may not have explained very well in the last video. Oh, drug off too much. Alright. So we're just going to demonstrate normally open, normally closed contacts. You see how both of these have the exact same address and they're following this coil with the address. So this one and these two are all three associated together because of the address. So when I press this start button, basically what it's going to demonstrate is the difference between this normally open and normally closed contact. They have the same address. One's normally open, one's normally closed, so they're always going to be opposite of each other, okay? So here we go, buttons coming on. See, the normally open is energized now. The normally closed is not. When I let go of the button, they swap states. So I don't think I covered that in the last video, normally open versus normally closed contacts. And that's definitely a concept that you want to make sure you understand. Alright, so let's do that same motor control, but instead of using the regular coils, we'll use the latch and unlatch coils that we kind of reviewed in the last video. So let me get that set up. Alright, so we're going to make our start button, turn on our memory. We'll make our stop button, turn off our memory. Then we'll make our memory, turn on our motor. Right there. So a little bit different than the previous rung, but we're going to get the same outcome. When I press the start button, the motor comes on. I can let off of the start button. The motor's still on. When I press the stop button, the motor cuts off. You know, same on and off functionality that we had in the last example. The difference is here we're using a latch and an unlatched coil, whereas the first example we had a regular momentary coil and we were using that rung branch to seal in around our start button. So both ways are right. You know, there's no right or wrong answer. It's just different ways of doing the same thing. So let's say that we can cut our conveyor motor on and off, right? But let's say for safety reasons, we want to add a horn, and whenever start button's pressed, we want that horn to play for like three seconds, just to let people in the area know that conveyor motor is going to start up. So when we'll press the start button, the horn will play for 3 seconds, and then our motor will start up. So let's do that. So we're going to need, let's make output 2 our horn, Boolean, and then we're going to need a timer. So let's make us a timer 1. And in this software we configure the timer over here, and we said it's going to be a 3-second timer. So pre is for preset, or consider it a threshold. So 3 second, and I put a 3 here, that makes this a 3-second timer. So let's change this circuit that we've already got started to make our horn come on. Okay. And then we'll add another contact for our same motor memory. Let's put us a timer in here. We'll make it timer 1. And then we need another contact that says when the timer gets done timer, when it reaches its threshold, that's this Q bit that we reviewed in the last video. Then we can cut our motor on like this. And then the second thing that we're going to want to do is we're going to cut that horn off once the 3 seconds have been reached. So we can do this. I think that should work. So when we press the start button, the M1 memory is going to latch, the horn should come on, the timer should start timing, the motor should stay off. 3 seconds later, this .Q bit of this timer should come on, which should allow the motor to come on. That should turn our horn off. So here we go. Start button's on. Timer's timing. The motor's off. The horn was on. There we go. Once it hit 3 seconds, motor came on, horn went off. So let me stop that. Let me press the stop button and cut everything off. And let's change this. That was kind of fast. So let's change it to a 10-second timer. That way we can watch it. Alright, here we go. So start button's on. Horn is on. Timer is over here timing. See the accumulated value? 6, 7. Once it hits 10, our output, our motor should come on. And our horn went off. The way that works, this timer has a couple different bits, a couple that we can monitor. And we're using the Q bit, and it comes on when the timer reaches its threshold, that preset value of 10. So one more time, here we go. We latched our memory, the horn is playing right now, our timer's timing, so the whole time that timer's timing, that horn's going to play, and then once it reaches the threshold, the motor's going to come on. So that gives everybody in the area a chance to know, hey, this conveyor's fixing to run. So let me stop it, and let's do one other little, change one thing about it. Let's replace that contact with a regular, a normally open contact, and instead of using the timer Q bit, let's use this timer.tt bit, which is the timer timing bit. So this bit should be on while the timer is timing. So this should be a 10-second bit right now. So let's demonstrate. I'm going to press the start button. See how this .tt bit is on and our horn is on? But once we hit our 10 seconds, that TT bit should go off. See there? So it's exactly the same outcome as we had using that .q bit in the normally closed contact. Just another example of it's more than one way to program something and get the same outcome. So I think that's a good place to stop today. We'll keep this video short. Let me know if you have any questions about this. Drop me a comment below and let me know if I need to go over something different, or if you have your own scenario that you want me to cover. Just let me know what it is and I'll make a video about it. So please subscribe to the channel so you can see the other videos that are coming. And thank you and bye.